Hello, everyone. My name is Philip Stanis, and I'm here to talk about AMP for email. Now, AMP for email is the youngest format of AMP. It allows senders to include AMP components inside of their email, giving users a rich, engaging experience in their inbox. Now, there's a lot of documentation and talks about how to actually use AMP for email and how to get started as a sender. So this talk is actually about how it works behind the scenes, specifically how email clients handle AMP emails and what are the steps needed in order to render one. Now, the idea behind this talk is primarily to demystify emails and how AMP fits into this email ecosystem. You're all AMP contributors, so you're familiar with AMP, and I would just like to explain the difference between AMP for websites and AMP for email, and what are the additional considerations that you need to take if you're developing AMP emails. Ideally, after hearing this talk, you would be able to build an AMP email viewer, something that would display an AMP email, which is especially useful if you're an email client. But I believe this knowledge is useful for any tool that's related to AMP emails. Knowing how it's rendered by the email clients, which consume the content and which are the user-facing products, is helpful for any sort of tool development. Even if you're not interested in emails, there are a few very interesting web features that I learned by working on this project that I will also be presenting. So I believe this knowledge can be useful in that regard as well. Now, this talk is split into two parts. First is how we're going to deliver the AMP code to an inbox. And the second part is how do we render this after we have received the AMP code. This talk is a bit content-heavy, and there are a lot of things and caveats to things, but I promise there will be at least one photo of a cat, if you pay attention. Now, before we continue, I'd just like to compare emails to websites and how they differ in terms of protocols. And this will help frame the conversation about delivery. Now, websites use this protocol that I've heard of called HTTP. And HTTP is a two-way protocol where a client requests a resource from a server. Makes an HTTP request. It tells the server which resource it's interested in, and it can provide some additional metadata about how it wants it delivered. The server then sends an HTTP response. Emails use different protocols. For purposes of this talk, the two important protocols are SMTP, which is used to deliver the email, and the MIME format, which is used to actually encode the email message. And the most important thing to keep in mind here is that email is generally a one-way protocol. The sender is pushing content onto an email client without actually getting information about the email client in return. It may get, if the email address is invalid, it may get that feedback, but it does not know how the user will view the email and what the email client's capabilities are. In fact, the user might view the same email in multiple clients, for example, on mobile and on desktop. So the sender needs to make sure that this payload is generic enough, and because it doesn't get any request, unlike HTTP. Now, the actual MIME format is very similar to HTTP. With HTTP, we have some headers containing the metadata about the request. They're then followed by the content. In this case, we have the content type header, for example, which says that this email is HTML, which is then followed by a line of HTML. With the MIME format, it's quite similar. We have some headers which contain metadata, and some of it is email-specific, like from, to, and subject. But some of it is exactly the same as with HTTP, like the content type or the date. And in fact, we use the same content of the email itself as we use with HTTP here, which is one line of HTML. And at this point, I would also like to mention that MIME as an acronym might sound familiar because there are MIME types. And the MIME type is text/HTML, which is the MIME type denoting HTML content. Now, MIME types originate from the MIME standard, but the MIME standard itself is how emails are encoded, which you can see on the screen here. The MIME types have been adopted by other formats and protocols ever since, but the MIME standard is about emails primarily. Now, going back to HTTP being a two-way protocol. When a client requests a resource, it can tell the server what kind of resource it can accept. And this is done using the accept header. In the accept header, the client can say, I will only accept content in the HTML format. And the server can then send content in this format. Now, this means that the server might have multiple versions of the same content, and based on the request, the server will give the correct type. Unfortunately, the accept header, which is key to this, can't be really done in an email. Not because we can't add this header, but because there is no request to begin with. Email is a one-way communication, so the sender needs to make assumptions about which formats the email client supports. Hopefully, the email client supports the format in which the email is encoded, but if it doesn't, then the user would either get gibberish or would not get the email at all. This is a difficult problem, but the email spec does have a solution for it. The idea behind this solution is very simple. We will include multiple versions of the same format and lay them in front of the email client, similar to this smoothies, and then the email client gets to pick which one it wants to use. The way this is done is using a special MIME type called multipart alternative. We have the same email from before, but now instead of text HTML, we're using this content type, multipart alternative. What you'll notice here is that we also need to define a boundary. This is an arbitrary string that we'll use to separate different parts inside of the same email. So the first part here is, for example, plain text, just hello world. It has a different content type, as you can see. In fact, the content type is defined inside of the part itself, and we use the boundary string to separate it from the other part. And the other part is HTML. So now we have one email that's using multipart alternative, and it has two parts inside of it, the plain text part and the HTML part. And according to the spec, they are in reverse preferred order, meaning text HTML in this particular case is preferred. So if the email client can render HTML, it should. If the email client doesn't support HTML, or if it supports HTML but the user has, for example, chosen a setting to disable HTML, then the email client can simply pick the other format, which is plain text. The idea here is that there should be content parity between them. So in this case, in both cases, the user would see the text hello world, but the HTML content is slightly richer because you can use HTML markup. At the end of the day, the sender is saying, look, whichever format you pick, you would still get the same content in the end. I prefer HTML in this case, but the email client can pick a different format. And you can probably see where I'm aiming at here. Multipart alternative allows us to have more than two formats. This means that we can include another format, which is the AMPHTML. So in this same email, now we have plain text, HTML, and the AMP part. We use a different content type for the AMP part, text x AMPHTML, to differentiate it from the text HTML, even though this is technically HTML as well. Now, in this case, the sender is saying, I prefer that the email client renders the AMP part. If it can't, it can render HTML, or it can render plain text. This means that an email client that does support AMP may choose to render the AMP part, but even the email clients that don't would still be able to render the email. They would just fall back to a format that they do support. In fact, because this is defined by the MIME standard long ago, even older email clients that have been last released before AMP for email existed would still render this email. They would see the AMP part, they would not recognize the content type, and would just fall back to the next available format, which may be HTML or plain text. So now we've seen how the AMP code arrives from the sender to the email client. The second part is, what do we do with this code? How do we render this AMP? And before I talk about AMP, I really want to talk about rendering HTML emails and how this works right now. This will set some important context about how AMP is rendered as well. So these are generally the steps that are already done in your email clients and anytime you view an HTML email. And this is oversimplified, but to frame this conversation, I would like to say that we have two privacy-related rules that every email client respects when they display an HTML email. Rule number one, if there are any external links, then the HTTP referrer should not be included. Normally, when you visit a web page and you click on any link, the website that you're navigating to will get the referrer header, and it will know which website you came from. If you click on a link inside an email, this external website would get the referrer, which is the email client. The problem is the URL might contain information such as the email ID, maybe even some session information, and it's very important that this is never revealed to the website that you're navigating to. Second rule, if there are any external HTTP requests made inside the email, this should not leak any browser or user information. What are external requests? Images, for example. If there's an image that's hosted on an external server, then the browser requesting this image will include some information about the browser, like the user agent, it might include cookies, and all sorts of things. Now, the rule here is that once this happens, this server should not learn anything about the user or their browser. By viewing the email, you should not reveal any information to this external server. So these are the two rules that email clients implement generally for HTML emails. At this point, I would like to narrow the scope slightly to Webmail, which are email clients that are run from the browser. There are other email clients, such as desktop clients, which may implement these rules differently. But for Webmail, it really boils down to performing these steps. We get the HTML, we find all hyperlinks, which are the anchor tags, and we replace the URL with a redirect to the real URL. In this case, we have a link to amp.dev, so we're going to replace this with a redirect that would still take us to amp.dev, but strip the referrer. Then we find all images, and we replace each URL to an image with a proxy server. The proxy server is maintained by the email client. And what it does is very simple. On the server side, it downloads the given image and then just serves it back. This means the image has been downloaded from a server of the email client and not from the user's browser. This means that the server hosting the image doesn't get information about the user agent, doesn't get any cookies, and in fact, it doesn't even get the IP address. The IP address will be the email client's servers. And this ensures privacy for all external images. In the end, this is how, after processing, our HTML might look like. We replace the link with a redirect, and we replace the image with a proxy, both of which are hosted on our fake webmail server, webmail.com in this case. But for a real webmail client, this would be both of these would be on a server controlled by the webmail. Finally, we need to process CSS. Malte mentioned earlier that there are some ways of fingerprinting using CSS, such as media tags. So email clients will generally strip these. There are also things like background image, which we either need to proxy or remove altogether, again, to ensure that the privacy rules are met. Now, this was all about HTML. The next part is how this relates to AMP and what we do differently when it comes to AMP emails. First thing first, email clients generally go through several steps to determine if an email should be displayed at all, or if it's going to be displayed, if it should display the AMP part, or if it should just ignore it. First of all, email clients will apply existing spam and phishing checks that they may already have in place. AMP emails are not special and should not bypass these in any ways. So if the email has elements of spam or phishing, it will probably skip the inbox altogether, or worst case, it might appear in the inbox, but the AMP part should not be displayed. Many email clients have a registration process where they only allow senders that have met certain criteria send AMP emails. So they verify if the sender of this email can send AMP. The email should be sent using TLS, which is just similar to how using HTTPS is better than using HTTP because the connection is secure. The email sender should also be who they claim to be. As you saw previously, the from is just a header inside the email that can easily be spoofed. But there are existing techniques that email clients use to ensure that the sender is who they claim to be. Finally, the email should contain AMP, and this AMP should be inside multipart alternative segment that I described earlier. An AMP email must always have another part, either plain text or HTML. Otherwise, email clients that don't support AMP would not be able to render this email. So to make a valid AMP email must contain an HTML part that's, when it comes to content, at least has content parity. Finally, when we've passed all these checks, we get the AMP part and we run the validator on it. And this already makes sure some things are true. For example, we are sure we don't have any external JavaScript, and we only allow some components which are part of the email spec. Now, once we've done that, we have some valid AMP code. What we're going to do with this is pretty much the same we did for HTML. We're going to find all hyperlinks, anchor tags, and we're going to replace those URLs with redirects. Then we're going to find all images. We're going to replace those URLs with our proxy, so that images in the AMP code would also not make direct requests to the server. Finally, we're going to apply the same CSS transformations. Unfortunately, this is not enough, because the AMP email might be dynamic. And what I mean by that is two things. We might have components like AMPList and AMPForm, and these components will make external requests to a server similar to images. So we need to make sure we proxy these as well. Otherwise, when the AMPList fetches the JSON content, the server would get user agent, or it would get some cookies. And these are things we want to avoid in an email. More importantly, if our AMPList has AMPMustache, or if our AMPForm has AMPMustache, then we might be creating new elements on the page. We might be creating new images or new hyperlinks, and we need to make sure we do the same thing with these that we did to the email itself, like replacing images with a proxy and replacing URLs with a redirect. Finally, with all this aside, we need to keep in mind we are displaying arbitrary HTML in the user's inbox. Technically, HTML emails are also arbitrary HTML, but in that case, they are much more limited in terms of what they can do. AMP emails can contain a lot more, like custom JavaScript. So we need to make sure that in the worst possible case, this email is displayed in a secure and privacy-preserving manner. And the first thing we're going to do is display it inside an iframe. This is not necessarily the case for HTML emails, but for AMP emails, it's a must that we use an iframe for every email. If we have multiple emails displayed on the same page, we will use a separate iframe for each AMP email. Now, once we've done so, we can actually leverage a technique that's already used in another situation where AMP is displayed in an iframe, which is the AMP viewer. For example, the one used by Google Search. Google Search also displays AMP inside an iframe and uses something called the AMP Viewer Integration API. The AMP Viewer Integration API is like a special AMP component that, when added to a page, will make the AMP document that's inside an iframe talk to the page that contains the iframes. What this means is that now the page that has the iframes has a certain degree of control over the AMP runtime. And the AMP runtime would also report things to the page that contains the iframes. Now, what this actually provides can be quite complex, because we have different parameters that we can give to the AMP viewer integration, where we tell it what are the things we want it to do. One of the examples is we can tell the AMP viewer that we want it to report any errors in the runtime. So in this case, we have an iframe, and if there is some error in the AMP page that's inside the iframe, and we enable this parameter, then we will get a post message saying what's the error that happened to the parent page. However, there's something way more useful that we can do using the AMP viewer that's relevant for emails. We can ask the AMP viewer integration component to block and intercept these two operations. First is any HTTP request made using JavaScript, meaning XHR or fetch. Second is any attempt to use AMPMustache. If we enable this, then the AMP viewer will prevent the AMP runtime from running this directly. Instead, anytime an HTTP request is made or an AMPMustache is called, the AMP viewer will ask the parent page what to do. And this is best illustrated with an example. We have an iframe that's on a parent page, and we have enabled the AMP viewer integration. At some point, the AMP runtime tries to call fetch. This could be an AMP list, for example. Now, the AMP viewer integration has intercepted this and prevented the fetch from happening, so there was no HTTP request yet. Instead, it will send a post message and ask the parent page what to do with this. The parent page, in our case, will still perform fetch, but it will use the proxy, the same one that we use for images. So now the parent page has still made that request, but it's been proxied. So the JSON endpoint for AMP list is now proxied using the same thing we use for images. And once again, we ensure that no user information has been leaked. When the fetch is done, we send another post message and we let the AMP page know. From the perspective of the AMP page and the AMP runtime, it looks like a fetch has been performed. What really happened was that the AMP viewer has asked the parent page to do it. And the same thing goes for AMP mustache. Anytime there's an AMP mustache on a page, and this is when this is about to be rendered, instead of rendering it, the AMP viewer will ask the parent what to do. And the parent page, which is the Webmail client, will render this template, and then it can perform the same transformations we did on the email. So now we can replace the URLs of images and the URLs of any hyperlinks that are added in this process. So one of the last questions to answer is, where do we host this iframe? We shouldn't publicly host the email content. Unlike a website, it's not public. It's only meant for the recipient. And the second problem is we must have a different origin from the email client. If we have the same origin, then we have a same origin iframe that can communicate with the parent page, which is not good. In case there is some arbitrary JavaScript somehow injected into the email, then it can access the user's whole inbox. In fact, if we have more than one email, we need to make sure each iframe has a different origin. Otherwise, these iframes can talk to each other. So for example, again, in case of some arbitrary JavaScript, it could, in theory, talk to another email on the same page, because they have the same origin. There are two possible solutions. One is straightforward to explain and very hard to actually do. You set up your DNS to have a new random subdomain for every single email. So in this case, you do have a different origin because you're generating them randomly every time you display an email. Second option is to use something called an opaque origin. This is defined in the web spec as a special origin that's considered cross-origin with every other origin. In other words, if we have two iframes and they both have an opaque origin, they are considered to have a different origin, no matter what. To do this is very simple. The easiest way to do it is to use a data URL or a blob URL. If we do this, then we get an opaque origin, and this iframe is considered a different origin from each other iframe. And this also solves the first problem where we are never hosting this AMPHTML. We're just using a data URL to inject code into our iframe. But there is one more thing. To make that sad-looking cat happy, we need to make sure there is a certain level of security when we display emails. So the final thing is that we probably want to use a content security policy when we display emails. And with a content security policy, we tell the browser what are the resources that are allowed on some HTML page. If the browser sees a resource that's not allowed, it will block it on a browser level, which adds a very high degree of security. One example here is we can have a content security policy that says we only allow scripts hosted on the AMP CDN, and we only allow images hosted on our domain. In this case, again, I'm using webmail.com as an example. It's not a real email provider. If we have this content security policy, the browser will allow us to have a script tag to load v0.js, for example, and it will allow us to use our proxy server, which is technically on our domain. But if we somehow have someone inject another script tag that's not the AMP runtime, the browser will block this because it's hosted, in this case, on example.com. And thus, because it's not on the AMP CDN, the browser will not allow this script tag to even be downloaded, let alone executed. Also, if we somehow forget to proxy an image, we have told the browser that we only accept images hosted on our own domain. So this image is on another domain, and the browser would not display it, and it would not make the request. If we use a content security policy, this means that we ensure that even if there's a bug in our code or if something goes wrong, we still limit the amount of things that can happen from an AMP email. There is another problem, though, and this is the last caveat of this presentation. Because we're using the opaque origin, by spec, this means that the iframe is inheriting the content security policy from the parent, unless the iframe has a different content security policy in the HTTP headers, but we can't do that because it's a data URL, which doesn't have any HTTP. In other words, our iframes, at least the way I described them previously with data URLs, will have the same content security policy as the Webmail client. And this is not ideal in most cases. In most cases, we want a more strict, or in general, a different content security policy for the AMP emails compared to the email client itself. The solution to this is to use two iframes. The first iframe is a bootstrap page. It's a static HTML page that has some JavaScript on it, and it's initially empty. And it's the same for every email. And this static page is returned with CSP headers. So if we put this in an iframe, it will override the content security policy, and it lets us define one for our emails. Then this page will wait for the email client to give it some AMP code, usually using a postMessage. It will create the second iframe inside of itself, which actually contains the AMP code. So then we have the outer iframe, which is a normal HTTP served iframe that has a content security policy, which creates another iframe inside of itself, which has an opaque origin, meaning it's isolated from the rest of the page and from other emails on the page. Finally, we have the inner iframe. We have the bootstrap page relay messages between the inner iframe and the parent. So from the parent page's point of view, this looks like it's just one iframe, because the inner one is just relaying all the messages back and forth. I know this presentation was a lot. There are caveats on top of caveats on top of caveats here. So the good news is, and this is where the contributor part of this summit comes into place, I would like to announce that we're currently working on an AMP email viewer library. The idea here is that we're going to build an open source library that will perform all of these steps, and that can be used by email clients and other email tools, and anyone who wants to display an AMP email in the same way that email clients would display. Currently, it's an empty GitHub repo, and work is just starting. So at this point, if you're interested in AMP email or in this project, I invite you to watch this repo, and if you're contributors welcome as always. And this is a chance for you to contribute to this project from day zero, basically. If you have any questions, feel free to reach out to our working group on Slack or to me directly on Twitter. Thank you.